Consider this word problem. You're doing some home renovations, and in one of the rooms you wish to replace the floor. You go ahead and measure the length and width of the floor to be 115 inches by 132 inches. In doing so, you use a measuring tape. And the measuring tape is measured in inches and also in centimeters and millimeters on the other side. But in this particular case, you chose to use inches. And you chose to measure it in full inches, 7 to 8 inches, 8 to 9 inches, in complete inch increments. Not in the smaller increments of the inch, the eighth of an inch, the quarter of an inch, but in whole inches. 115 inches on one side, 132 inches on the other side. And this becomes important when we do significant figures at the end of this video. So everything has to be in whole inches, not the increments of an inch. So go ahead and make those measurements, 115 by 132. When you go to the store clerk tells you they only sell it in square feet or by the square meter. So you need to convert your inches into square feet or square meters. First thing we're going to do is make a sketch. Here is a sketch of the floor. And on one side it is 115 inches long. And on the other length it's 132 inches. For the sake of completeness, 115 inches can also be written 15 inches, and it can also be written as 115 using these quotation marks as short to represent inches. In order to calculate the area of this, it's the area of a square, the area of a rectangle, length times the width. So the area of the floor is equal to the length times the width, 15 inches times 132 inches. Putting these numbers in the calculator, the answer is 15,180. But now we got to look at the inches as well. Units are operated on just like the numbers. So we need to multiply inches times inches. Inch times inches comes to inches squared. How did I get this? Well, consider. 115 to the power of 1 is also 115. All numbers can be to the power of 1. If this was 115 to the power of 2, that represents 115 times 115, each one of them to the power of 1. And when you multiply two numbers together, consider these to be the base and to a power, we write down the base. 115 has to be the same base. And then you add the powers, 1 plus 1, and that's equal to 115 squared. Same thing applies to the units. We have inches to the power of 1. And units are operated on just like the numbers are. Times, and we have inches to the power of 1. When we multiply the 2 inches together, it has to be the same base, inches and inches. It can't be inches and feet. Inches and inches, and then we multiply the powers, or add the powers, excuse me. 1 plus 1 is equal to inches squared. And that's how we get our units of inches squared. The conversion factors now we're going to use. Okay, we have to change square inches either into square feet or into square meters. The conversion factors that we're going to use for this particular word problem is 12 inches is exactly equal to 1 foot. And we can see that here on the measuring tape. I open up this measuring tape right here. 12 inches is also 1 foot. The conversion factor in this form is basically an equality. What we really need is the working factors. So I can take these two and put them one over the other into a working factor. It's 12 inches, looks like this. 12 inches is to 1 foot, or 1 foot is to 12 inches. And I call these the working factors. This one here will be the equality. Commonly, these are the conversion factors themselves. And conversion factors, they come from a chart. Here it is. And they're all given to you here as equations or equalities. Our task is to change these equalities into working factors, such as this one right here, so we can use them. And I'm going to carry on. We need to find the area. I'm going to go with the area in square feet first. Let's find the area in square feet. So we need to convert 15,180 square inches into square feet. Area in square feet is equal to, first thing we do for a conversion is write down the number with the units that we want to convert. And that number is 15,180 inches squared. And we're going to multiply that by these factors. And the rule that I use here is one that I coined some years ago. And that is follow the units. And the numbers go for the ride. That's how we're going to operate on all units, even in our equations, especially in conversions. Follow the units and the numbers go for the ride. Here is a number. We're not too interested in the number when it comes to conversions. We're interested in the units. We want to change inches squared into square feet. Here's our factors. Need to cancel out the inches. Looking at what we have here, inches here is in the denominator, inches here is in the numerator. How do I know that inches are in the numerator? Well, all numbers are fractions. Everything can be divided by 1. The number divided by 1 and the inches divided by 1 doesn't change anything, but it tells us visually that this is in the numerator and here is the denominator. In order to cancel out the inches in the numerator, I need to put inches in the denominator here. So I'm going to use this one. Inches in the denominator such that they cancel out, and then feet go on the top. Follow the units. And the numbers go for the ride. The inches, 12 is in front of the inches, and 1 foot. I've done this only for 1 inch. Here there are 2 inches. Recall above, inches times inches equals inches squared. This converts only 1 inch, but I need to do it a second time in order to convert it twice. Times 1 foot divided by 12 inches. Now inches, 2 inches here and 2 inches on the numerator cancel out. That effectively changes this into square feet. Doing the multiplication now. Area in square feet is equal to 15,180 times 1 times 1 divided by 12 divided by 12 gives me the number of 105.416666 repeated. And the units will be feet times feet, same as before, feet to the power of 1, feet to the power of 1. Add the exponents, becomes 105 square feet. Now we need to reduce this to proper significant figures. To do that, we need to know how many significant figures were used in the original measurement. Brings us back to the original word problem. And you'll see that the original measurement was done to 3 significant figures in inches and 3 significant figures here. We're not going to use this one, even though when we multiply the 2 together, we wind up with 1, 2, 3, 4, maybe 5 significant figures, depending on where you want to put the decimal point. But we're only interested in the actual measurement, which is 3 sig figs and 3 sig figs. Reducing this now to proper significant figures, 1, 2, 3. We look at the 4th one. And if the 4th digit is less than 5, we round down. If it's greater than 5, we're going to round up. In our case, the area in square feet and is equal to or approximately 105 square feet. Now you may ask yourself, why didn't I use this one and 1, 2, 3, 4 significant figures as far as sig figs go? Why did I go back to the original one? I'm going to show you that in the next half of this video using square meters. So let's go ahead now and convert this area into square meters. I have the problem here rewritten on the length sides of the page, so I'm going to need a little bit more room for this one. And we want to find the area of the room in square meters. So the area in square meters is equal to the length times the width, same as before, except now instead of doing the multiplication, I'm just going to use these numbers right here, the length times the width, times 132 inches. That effectively is the area of the room, of the floor, should I say. Now I want to change inches into centimeters, and then eventually centimeters into meters. The conversion factors that I'm going to use is 1 inch is equal to 25.4 millimeters. Going over here to the conversion chart, we also have 1 inch is equal to 2.54 centimeters. They're exactly the same thing, or 1 inch is equal to 2.54 centimeters. And these are known as exact values. Something special about the inch and the centimeters, and the millimeters, should I say. If you go into this textbook, it's a very good textbook for metrology. There's a small comment in here, which is important to note. There are 3 countries in the world that use the inch. There were Britain, Canada, and of course the United States. These 3 countries came to an agreement and decided that 1 inch is to be exactly equal to 25.4 millimeters. This is an exact value. Using that as an exact value, 1 inch is equal to 25.4 millimeters agreed to by the 3 countries as mentioned above. And what exactly do I mean by exact values? It means that if I rewrite this, 1.00000 continuing inches is equal to 25.40000 continuing in millimeters. That means I can use as many significant digits as I want in this conversion factor. And this conversion factor, therefore, has absolutely no impact whatsoever in determining the number of significant figures in the final answer. Make a note of that. Conversion factors do not impact the number of significant figures in the final answer. As before, we need to change inches now into, we can either go to millimeters or centimeters. I'm going to choose the centimeters route. Draw a division sign. I'm going to have inches in the numerator, therefore I need inches in the denominator. Remember, follow the units. Inches need to be in the denominator in order to cancel out. And I'm going to put centimeters in the numerator. And the numbers go for the ride. The centimeter has 2.54. And the inches is 1. 1 inch. And 1 inch cancels out, but I have to do it a second time for the second inch. Times 2.54 centimeters to 1 inch, and inch cancel out again. This effectively changes this to square centimeters, centimeters times centimeters, but I need to go to square meters. And we all know that 100 centimeters is equal to 1 meter. Using this conversion factor, carrying on, multiplied by, I want to cancel out the centimeters, so I'll put centimeters in the denominator, and then the meters will go in the numerator. And the number for the centimeters is 100 and 1 meter. That takes care of 1, but I have 1 left over, so I have to do it again. 100 centimeters cancel out. This effectively, all of these numbers effectively changes the 115 inches by 132 into square meters. Now doing the actual mathematics in a calculator, the answer will come to the area in square meters is equal to, multiplying all of this and then dividing by 100, the answer will be 9.793528, and the unit is meters times meters, meters squared. Now rounding this to the proper significant figures, all conversion factors, right here, are exact values. I can put in as many significant digits or as many numbers behind these numbers as I wish. They have no impact on the number of significant figures in the final answer. Only the measurement does. And the measurement was in inches, in whole inches here. So we have 3 significant figures in the original measurement, 3 significant figures in the other dimension. Therefore, this needs to be reduced to 3 significant figures. Area then in square meters is approximately equal to 9.7. You look at the fourth one, less than 5 round down, greater than 5 round up. This is less than 5, so we're going to round down. And the unit is 9.79 square meters. But, and this is a big but, in real life, when you were doing something like this in real life, and you have made a measurement to a room, and if you decide to round down to this square meters, you're obviously going to be a little bit short in the amount of material for that particular floor. It would be wise then to use your common sense in real life. Instead of ordering 9.79 square meters, order, say 10 square meters. Because they're sold in square meters, so you'll order 10, and you know you'll have enough in case there's any reason for scrap. For physics purposes, this is what we're going to do for physics. For real life, use your common sense. When it comes to rounding.